All right. Good morning, everybody from Tucson, Arizona. Welcome to today's webinar. Today, we're going to be discussing regional structural geology and its implications for the mine site. We've got our panel of experts today, and we've got some of your pre-submitted questions. We hope you have lots of live questions as well. So this webinar is brought to you by the Geotechnical Center of Excellence. We are at the University of Arizona, and we are part of the School of Mining and Mineral Resources. We are an industry-funded group, and we are member-led, and we are an interdisciplinary center as well. We pride ourselves on our collaborative geotechnical research and education like the course that this webinar is based on. And we also strive to bridge gaps within and between academia, industry, and other fields of study. So as I mentioned, the GCE is member-funded and member-led. Here is a list of our wonderful member companies, so I want to give a big shout out to them. If you are tuning in today and you do not see your company represented here and you think that you should or you'd like to be, please reach out to any of us at the GCE, or you can send an email to gce@arizona.edu, and we'd love to have that discussion. So this webinar is based on our professional development course, Structural Geology for Geotechnical Professionals. You can see it started on August 6th, but you can still register. It is a 12-week online course. It's comprised of pre-recorded videos. It's about 26 hours of pre-recorded videos. There is a live component, so to speak, in that it's a 12-week release, but the content is open for an entire year. So all of you busy professionals can continue to watch and learn from the content for a whole year. So if you'd like to learn more about that or register, you can click the QR code. We have 4 of these professional development courses in total. So if you'd like to learn more, you can check out our website or you can send us an email. This course was also underwritten by the Large Open Pit Project, so a big shout out to them for helping us out with that. And as always, a big thank you to our panelists today, our course advisors, and all of our collaborators. This is a huge endeavor to put these courses together, so we want to give them a big thank you. So just a couple of housekeeping notes. If you are tuning in today as a participant, you are automatically muted and your video is off, so don't worry about that. If you'd like to ask a question at any time, you can use the Q&A function, which is at the bottom of your Zoom control panel. There's a chat function and a Q&A function. They look similar. We encourage you to use both. The chat is more for chatting, but if you have a specific question, please use the Q&A. It helps us a lot. Your questions can be anonymous. If you'd like to pose your question to a specific panelist, you can include their name as well. And you can also vote for other people's questions with a thumbs up if you'd like us to address that one. This is a recorded webinar as well. We'll be posting it to our course site as well as our YouTube page. And there's a disclaimer here that I won't read in full, but just to summarize that this is for educational purposes only. If you have any site-specific geotechnical issues, we encourage you to seek professional advice. Okay, so we'll start with a couple of introductions for our panelists. Starting with the hosts, I'll be your host today. My name is James McNabb. I'm a Senior Research and Development Engineer here at the Geotechnical Center of Excellence. Joining me today also from the GCE is Julia Potter. She is our director. Good morning, Julia.
Thanks, James, and good morning, everybody. Thanks for being here today.
Next, we have Benjamin Meyer. He is our Research and Development Software Engineer. Good morning, Benjamin.
Good morning, James, and everyone. Thank you for joining us.
And next, we have Alma Resner. She is our undergraduate researcher. Good morning, Alma.
Hi, good morning.
All right, so those 3 will be working hard in the background to field your questions and making sure that everything is going smoothly. Okay, let's introduce our panelists today, starting with Amanda Hughes. I don't know if she's on right now. She might be a little bit late, but she should be joining us later. She's an assistant professor of practice at the Department of Geoscience here at the University of Arizona. So hopefully she'll join later, and she is a wonderful resource. Next is Iris Linauer. She's a lead structural geologist with WSP Global. Good morning, Iris.
Good morning, everyone. Happy to be here.
Next, we have Jeff Owen. He's a manager of structural geology and mining operations and advanced project exploration with Tech Resources Limited. Hello, Jeff. Thanks for joining.
Hey, good morning, everyone.
Next, we have Luca Zorsi. He's a principal geoscience specialist with WSP Canada. Hello, Luca.
Hello, everyone. Thank you for joining.
Next, we have Ian Besson. He's a principal member of Tech Geological Consulting. Hello, Ian, and good evening.
Hi, everyone. Hi.
All right, so that is our panel, and now we will get into some questions, starting with a quick kickoff discussion to kind of set the stage. So why should mine stakeholders care about the structural geology in the region of their mining operation? This is kind of the meat of today's topic. You know what? I will kick it over to Jeff to start, just to get things rolling.
All right, straight to the hot seat. Okay. No, it's a great question. And I think some of the benefits of the mine stakeholders understanding the structural geology in the region is it was for a couple different things. Is sort of understanding what your regional patterns are can also help influence what your localized patterns are within your mining operation, and understanding what I guess these orientations are can help you, and I guess the rock characteristics or the fault characteristics can help you with certain things like your resource extension. If you're trying to look for a resource that's maybe just proximal to the mine, that can help you with short-term reconciliation as well with your KPIs. If you're more of the hydrogeologist, just understanding maybe how some of these faults or joint patterns could be acting as conduits for your hydraulic conductivity. Yeah, I think there's a number of different benefits from understanding the structural geology in the region of mining operation. I guess those are just some of the ones that sort of come to mind quickly here. Yeah.
Great, thank you, Jeff. Anybody else? Big topic, high level.
Yeah, I mean, we could speak about this for a long time, right? The people that work on mines are normally subsequent to its opening, so they'll have arrived there a year or two or many years after it got started. So they will be working sort of in the matrix, if you like, inside the volume of interest that they're supposed to take data and control. So there's a very good chance that they won't have had sight of any of the exploration stuff, you know, prior to the discovery. So they'll really be working in a bit of a box. And as a consultant, you understand that quite quickly. And because of that, they can maybe be measuring or get stuck in a rut and measure only a certain range of features where maybe they need to broaden their view and take a step back and maybe even go and speak to the exploration folks, you know, and have a cup of tea with them to see what they've seen on the large scale. So there's lots of good reasons to go and, you know, spread your view a bit wider. For us, it's important to get an idea of the style of deformation, right? What is the form of your folds? What's the style of your folding? What's your, you know, is there brittle ductile overprint, etc. So those things, because structural geology is fractal, will chances are they'll also be present in your mining volume. So if you can get a handle on that, it really does make your life easier, I think, as a practitioner on a mine to do your daily job. And as a consultant, it's always a good place to start, right? Because, you know, it's a very sort of easy, hands-off, early thing to do. You can do it in your office before you go to site, and that'll just tune you into the setting. Also step out a bit broader and have a look at the other deposits in the area of your mine. There's going to be surrounding mines that may have more detail or even data than you'll find on the mine you're looking at right now. So there's lots of reasons to do this, and I won't go on, but I'll hand over to other people.
Great, thank you, Ian. Let's go through our whole panel with this question, actually. How about Iris? Would you like to take a stab at it?
Well, there's several aspects, I think, where the structural geology falls in terms of being more efficient and more safe, especially going into geotechnical hazards. Understanding the structural geology will help you predict where the hazards are going to be. So that's a potential financial implication. There's ties into hydrogeology, understanding where there might be issues with water coming in. And then in regards to understanding the geometry of the resource itself, they're often structurally controlled, and a better understanding of where the resource continues or might be cut off could help planning the extraction phase and be more precise in that. So there's quite a few aspects where the structural geology flows in from both the resource and the geotechnical side.
Great, thank you, Iris. Luca?
Yeah, I mean, nothing much to add. I think it was cover all the major upside in taking a good step of the structural geology of the region of each of the mine, how that is important, right? And just highlight more what we just here said about the hazard side of things as well, and making the mining operation more either safe as well, or even more performing, in the sense that you can be more say you can have a better handle on how even to extract your resources if you have a good understanding of your geology and your structural geology of your region. So you're just simply improving the way and making more efficient even the mine cycle as a whole, even a closure too. So nothing more to add, because everything else was just already laid out by other panelists.
Great. Yeah, thank you, Luca. Yeah, so I think a lot of our questions today were sort of touched on at a high level with that first question. But now let's dig into them a little bit deeper here. Start with our first question.
James, sorry, can I?
Oh yeah, please.
I was going to add one other thing, actually. I was just thinking about
You
this
bet.
more, and I think sometimes what we'll do as a company or as consultants will often look at, to Ian's point, right? You show up there and you haven't had a lot of context around the area, and so we do rely on these structural patterns in the region to help us maybe sort of better understand what is happening on a mine scale. And I think that is a really, really good approach. And I think one thing I just wanted to maybe highlight is some companies have done this though, where you're moving through like scoping through PFS and into FS, and I think sometimes they might skip the step of actually following through with the appropriate data collection to push a mine into FS. And it has actually, just as a cautionary note, I think it's a great approach to use the regional structural patterns to help be more predictive for your mine. But also need to throw in that cautionary note that some operations in the past have done this at almost like a 90% write down in their resource because of this. So even though I think it's a great path to follow, I just wanted to highlight it's really important to follow through with these different levels of study, really do the data collection, really understand what the local structural geometries are in your mining operation for everything the panel's already mentioned here: geotechnical design, optimization, hydro. Yeah.
It's great addition. Thank you, Jeff. All right. It looks like Amanda has joined us as well. Good morning, Amanda.
Morning, James.
So we were just going through our first question. If you would like to give your opinion here, which is, why should mine stakeholders care about the structural geology in the region of their mining operation? High level.
Yeah, I feel like Jeff's answer just really captured it. I just caught the end of that, and that sounded exactly right.
Yeah. Great. Okay, let's move on to some of these more specific questions here, starting with this one. So, as a mine site geologist, I'm always trying to tie my observations with what I know about the regional geology, but I find that these endeavors are usually viewed as personal interest projects and not taken seriously. How can I convince management that these projects are worthwhile? Very interesting question. Dealing with management is almost more difficult than dealing with the geology.
The geology may convince the management on its own simply by falling down. That's the short answer, right? So it's a very difficult issue. So unless something has gone wrong, management will always be reluctant to spend money or time or give their attention to these kind of things. So we find a tech that we're normally the kind of fix-it guys. We get called in after there's an issue. There's a drilling program that's dud or that is erratic, and they don't quite know what they're getting, or there's a failure or loss of bench definition. So unfortunately, it's normally reactive. And unless it really hits the bottom line or closes down a ramp or delays production, there's not a lot you can do to convince management that these projects are worthwhile. That's not to put a negative view on it, but that doesn't mean you must stop trying. But yeah, that's my experience, if you like, on that question.
Yeah, great. Thank you, Ian. Anybody else would like to chime in on that?
I might add something to on what Ian was saying. As an advice, because I think like the question is leaning toward what can I do to to convince them. One of the things is that show the cost benefits equation. That's basically what it is, saying that any sort of decisions that is made, whether it's geotechnical, hydrogeological, or anything else, has to do somehow with the geology and the regional geology. So by laying down what it's unknown, by having done a thorough regional geology review of the area, by laying down these uncertainties and unknowns, will result in cost X or Y in terms of like type of investigation, as Ian was saying. Against that's what you can save in terms of money down the road if with a little bit more of a study of the regional area around your mine. And the reason it's a long-lasting issue. We all I think all of us and panelists have faced this issue, in which regional geology study are perceived to be just either personal interest or academic kind of like approach, when it's actually the old foundation of any sort of geological interpretation or even 3D model, for example. They rely upon detailed regional geology review, as Jeff was saying and Ian was saying earlier, because the fractal reason of the structural geology, because you put everything into perspective. And so the answer that we as geologists are providing are based a lot of the time by the regional understanding of the area or analogs, as Ian pointed out. So yeah, cost benefit approach is usually the best way for proving that this is required, because when you put down money in the equation, that management can start listening a little bit more.
Yeah, one of the things that we've also come across is that in the development of the project to the point where it can be mined, there maybe has been one or two or more structural studies done. So management can always refer to that and say, well, this kind of stuff has been done, but you really need to convince them that it needs to be done at a much finer scale, using a much denser, richer data set, regularly as you blast, in 3D, and the benefits will speak for themselves, I think in time. And the other thing is, not a lot of geologists hang around a mine for more than 3 or 5 years. So it's quite difficult to put these things into practice. But you're quite right. If you can show them the cost benefit of mining better or mining safer, you're on the front foot. Absolutely.
If I could add to that as well, I think it's been nailed here. And I mean, the question is, how do I convince management that these projects are worthwhile? And I find myself in this situation a fair amount as well, trying to convince that they should keep me employed, at Teck. And I think one of the approaches I try to take is I'll actually try to use case studies where I can. So, for example, 1 degree of change or 5 degree of change has this impact on your CapEx or your OpEx, right? So I find that management, when you start, they might not be sort of as technically familiar with the material that we're wanting to present, but if we show a case study where an operation has been able to steepen up their walls, and we say, this has actually saved $600 million from us doing a 2-month structural geology assessment, something like that can really make management pretty excited to continue it. And similarly, I guess taking that and using these case study examples, I think another step that can be done is taking it one step further and saying, okay, here's some visuals. Imagine now if we're going to we know the structural architecture for our mine site. Imagine we're going to do a drill program. How do we make this drill program more effective, more efficient, save meters? Are we drilling down a fault? Are we drilling perpendicular to it? So if you have the time, and I mean, I love the fact that this mine site geologist is trying to tie in their observations already. It maybe taking it one step further and say, hey, if we actually did this sort of drill plan orientation, or if we could see structures in this orientation for design impact, or even hydro constraints. So yeah, I think taking it that one step further, being like, here's some case studies and here's what I'd recommend.
Very good. Thank you, Jeff. Luca, I see your hand is raised.
Oh, yeah, I used the wrong
Oh.
wrong reaction. I wanted to
Okay.
clap your hand.
Thumbs up.
Well, oh no, yeah, it's just like just a good point, Jeff. Case studies is important. Yeah, both on, you know, that is also another way of providing more insight on things that went well, but also things that went wrong when, you know, in this case, talking about structural geology was underlooked. So yeah.
All right, very good. Okay, thank you all for that discussion. We've got a couple of live questions coming in. This first one, I think, has largely been covered in that last question, but I want to acknowledge Gonzalo for this, and maybe we've got some additions. So I'll go ahead and focus on this one. So investing in understanding the structural geology can reduce the risk of the overall project investment. Is that the common perception of mine operators or clients, or is it sometimes difficult to convince to invest in generating more structural data? So similar to what we've discussed, but perhaps a little bit of a twist. Do we have any more thoughts on this?
I'm biased on this one, but I feel like that the structural geology is still hidden sometimes, right? It's not in the forefront on a lot of things, in the sense that even as a requirement to be proven, we always regard everything in terms of geology or resource, right? But the structural geology part, I don't want to go down the route of saying that it should, you know, in a lot of the guidelines, you know, whether it's the NI 43101, the JORC, whatever, should be mentioned more often. And that would help, you know, the perception the structural geology is important. But even some of the requirements are not fully requiring, you know, a thorough structural analysis. You know what I mean? In terms of like regulatory, on the regulatory aspect. So that kind of might have a downfall in which there is a perception the structural geology is that it's just an add-on that could help every now and then. Not kind of one of the, you know, the important aspect for the comprehensive geological understanding of a deposit, along with detailed geological, geochemical, mineralogical studies. So they're all at the same level of importance, even for the definition of a resource, for example, which drives the economy of a deposit. We did find situation in which structural geologists have seen to be like, you know, the least important sort of like discipline when it comes down to the definition of an ore deposit. And then, you know, then it turns out to be one of the critical one, especially for their geotechnical and hydrogeological application for the entire mine cycle. That's sort of like a thought that I have on that specific front, to why sometimes it's not given the right, you know, the right importance to structural geology within a mining project, or like a general project in general as well.
Great, thank you, Luca. Any other thoughts on that? Like I said, hopefully this was largely covered in the last question.
I can contribute a little bit. We took a data set from a deposit in West Africa and sort of did this like, what would you call it, a sort of reductio ad absurdum, reduce it to the absurd sort of exercise. And we said, what if we intentionally model this data wrong and then quantify the incorrectness of it? So I'll send you the publication, but we modeled it. We created, I think, 1,140 models based on various ellipses and anisotropies, and then calculated the change in volume with respect to the actual volume, which we knew was correct because they'd had 2 years of mining on it, and the reconciliation was good. And then we drew up all these nice graphs to show how you can absolutely get it wrong using implicit modeling in Leapfrog if you don't take into account the structural geology properly, if you don't use the right anisotropy or prolation of your ore body. And we actually quantified it, and it came to around between 30 and 50% of overinflating the volume. And then we passed it on to some guys in Datamine, and we said, well, do a subset of these. I think they did 30 of them, and tell us how the contained ounces varied. And that was also, reflected the overblown volume. And that really explains how you can get write-downs from incorrectly understanding your structural geology. So it is a very real problem, and it happens at the handover from, all the hype and fluff and spin of opening the mine to actually getting into the nitty-gritty of development. Suddenly there's issues with the plant and the chemicals and the dilution and etc. A lot of that can be tied straight back to the fact that the ore body geometry is not right. And then there's lots of surprises and unhappy people. So yeah, to my mind, it does have a big effect. And I can send anyone who's interested that paper. It was published in 2022.
Very good. Thank you, Ian.
I might toss in something here as well, just something I'm thinking about as we're going through this question. And it's hopefully to the, Ian nailed it too with the just understanding the ore body. We want to avoid those surprises. And I was just thinking sometimes it is difficult to convince people to collect more structural data. And I guess one of the approaches we've had to take in the past is, how expensive is it to collect your structural data, and sort of what is the appetite for collecting it? And there are varying levels of costs associated with data collection techniques. So you might be able to convince them to collect basic structural data on a very cost-effective approach. So imagine looking at core photos and visually collecting alpha angle orientations from your core photos. Costs absolutely nothing, but it can actually have some downstream impacts. Whereas, escalating in costs, you could do anything from revisiting the core and doing oriented core logging up to televiewer logging and picking, or just reinterpreting some of that data. So I guess if it is difficult to kind of sell the idea of collecting more structural data, one potential approach would be to try to look at what are the most cost-effective approaches. What's a cheaper way of doing things to get some data? So at least you can maybe have a small win and then work your way up in the appetite of management and the operations.
Very good. Okay. Well, I'm glad we had some more thoughts for Gonzalo. Thank you for the question. Okay, we've got a couple more live questions here. Let's go to this one from Veronique. How can regional structural geology inform local versus far field in situ rock stresses? Local stresses in ancient greenstone belts, from my experience, are often perpendicular to foliation / belt trends from breakout analysis over core, etc. However, this is often different from inferred stress orientations from the present plate tectonic configuration. Can differences be related to locked-in stresses? And I think maybe I will kick this over to Amanda. Sounds like an Amanda question.
Sure.
To get us started.
Yeah, so there's three different times that stresses are being reflected in the rock mass, right? So the formation of the greenstone belts themselves are locking in anisotropy to the rocks themselves as they're deforming in the stress field that formed the deposit in the first place. And then when that is now subject to the kind of regional tectonic stresses in the modern state, there's kind of a far field regional tectonic stress. But then because those rocks bear that anisotropy in them, that can cause local reorientation of the stresses as well, because they're mechanically different. And so that could be part of the reason why you often would see, proxies for the far field regional stress telling you one thing and then seeing some local reorientation from breakout, because that's really reflecting how the far field stress gets modified in the presence of that mechanically anisotropic material. that's been deformed under a previous data stress.
Great. Thank you, Amanda. Interesting question, Veronique. Any other thoughts on this? All right. Very good. Thank you for the question, Veronique. Okay, we've got quite a few live questions coming in, which is fantastic. Let's go to this one from Irfan. Please share your expert opinion on the extent to which structural geology can help in estimating ore deposit knowledge. Secondly, how much is it necessary to study structural geology while carrying mine planning and development? Irfan. Pretty broad question. I think we will have a lot of good opinions on this. But do you want to get us started here?
Yeah, I think we're verging into the MRE part of the discussion, really. You can't divorce the geometry of your ore body, which in a structurally complicated ore body. I'm not talking about anything boring like bauxite or, you know, flat-lying stuff, tabular stuff. You can't divorce the geometry of your ore body from the structural setting and its structural analysis. So the extent to which structural geology can help in estimating ore body knowledge, ore deposit knowledge. Well, how did you find your ore body in the first place, I guess is the question. Chances are there was some structural understanding involved in that in the first place. So the question then is, well, why wouldn't that extend down to the mine volume or the stope, you know, locale where you're working, because it is fractal. So your knowledge has to be across all those scales, right? And if you don't have them across all your scales, you can be in for some nasty surprises. It's easier to correct stuff in an open cast environment, I think, than in an underground environment. If you've made a boo-boo. Yeah, it's a tough question to answer, but you definitely need to have it. And especially since things are getting deeper and more structurally complicated these days, the cost of deep-oriented core is getting higher and higher, right? You look at all those trends by, who's that guy? I forget his name, but he published a graph of showing the depth of new gold discoveries. It's clear that everything's getting deeper and probably more complicated. All the big sort of whales, the big ones at surface have been found. So now people need to look deeper and they need to look at less appealing, more complicated structural geology. So yes, you do need to know this. It's very important.
All right, thank you, Ian. Any other thoughts on this question from Irfan? If not, we've got Luca. I see you unmuted.
No, it's all good. Just tried to see if I could add anything more, but it's all good. No, I
Great.
think Ian covered it pretty much.
Good.
Yeah.
All right. Well, thank you for the question, Irfan. We've got quite a few live questions to get to, so let's keep moving. Here's one from Marco. Knowing that structural geological compression is the key first step to understand comprehension, my apologies, is the key first step to understanding potential ground behavior and serves as the foundation for performance-based design. Is there any reason in your experience for the lack of structural geologists in the industry? Why do you think management often doesn't see this as a gap and that needs to be addressed? Also, in your view, is this trend shifting in the right direction? Interesting question, Marco. Anybody want to get started on this one? Got a lot of structural geologists in the room.
Well, I
Tough one.
think it's, yeah, sorry. I think it's not just in the industry. There's, like, even though we have a lot of structural geologists right here in this panel right now, there's not that many structural geologists out there. And between academia and consulting, there's like not too many spaces left over for structural geologists working in the industry. And I think there's not a management demand for them. They'd probably prefer to have a resource geologist or someone who can work with geotechnical matters. And then often the structural geology parts get outsourced to consultants.
Yeah, I've been seeing quite a distinct trend in the larger consultant companies, SLR, MSA, SRK, and the larger mining companies as well. So Teck, BHP, Rio Tinto, and Anglo, where they are snapping up the structural geologists. So we've lost a couple, a 9-year employee and a 10-year employee to BHP in Australia quite recently, and another one to SRK in Toronto. So they are hunting good structural geologists at the moment. So for us, that's not a great thing because we work nicely with these people and then they leave. But the trend is definitely to upskill in structural geology. However, I've seen it mostly, the emphasis is mostly in regional studies, in compiling maps for sort of machine learning or AI exploration or weights of evidence exploration, not so much in the actual on the ground mining of things. It's mostly, the emphasis has been mostly on exploration and then target generation. That's been my experience.
Yeah, and what Ian was saying, to add on that one, there is a distinction between, you know, the type of structural geologists as well. What we can see is that the operational structural geologist, that it's something that it's difficult to find. Whereas the more generic research-based structural geologist or person that has like a predominant interest in structural geology on the general, like mine-wide or regional side of thing, that it's, let's say, easier to find, let's put it this way. It's a combination though of exposure as well. So there sometimes there is difficulty on exposing even young graduates to projects or a situation that will allow them to grow their experience, especially in an operational environment. So it's a tricky situation. But on the on the question, and I think Amanda might comment in a better way on this one, what we are seeing, you know, in Canada, but also in Europe, is a trend in a reduction in overall geology students. And so there will be a reduction in structural geologists in the next 5 to 10 years. Geology departments in Italy and some places in Europe are closing up. We have seen a reduction in some university in Canada too, and in some instances they were even questioning whether or not a structural geologist professor was even required in some of the universities. So it's a general trend that needs to be put in a larger perspective on where the industry is going, right? So it's kind of like a combined effect of several things, like exposure to projects, to maybe in 5 to 10 years a lack of, you know, graduates with the willingness of being exposed to structural geology on all levels, whether it's regional or local scale. And yeah, very interested in hearing what Amanda has, you know, what her thoughts are on this.
Yeah, I think that generally characterizes the trend overall of, although there's always individual cases where places are holding steady and growing and things like that. But in general, there is an overall decrease in the number of students enrolled right now. But in economic geology programs, it's been growing a bit because of all of the recent emphasis on critical minerals and an understanding that we're going to need, you know, large amounts of resources. So in some cases, in some places that's helped programs grow a little bit. Part of the reason I think that structural geology is a little underrepresented in the mining setting is that just historically, there's like inertia in the economic geology community that is more focused towards petrology, geochemistry, chronology, those types of things for both the academic programs, but then also for beginning mining geologists having that type of a background rather than a structural one, and that structural geologists maybe went into different fields and had a different focus. And I think that that's changing with several of the recent research group emphasis, like you mentioned, in Australia and in Europe, and that the recognition that that so much of the mineralization is structurally controlled or structurally compartmentalized in such a way that you can't ignore it, I think is growing, but that hasn't historically been the emphasis. And so I think that's maybe explains part of the underrepresentation of structural geologists in mining. Mhm.
Yeah, sorry, I just want to
You
add
need-
one more thing, in that it's not in a structural geologist's DNA to live and work on a mine for a very long time. Once structural geologists have taken their data and have cracked the problem and built the model, they want something new. They want to chew on something new. It's just the way we built. So if you do find a structural geologist, he or she will be in charge of multiple pits, maybe at a group level, but it's very rare to find a structural geologist on one mine. We hardly come across that.
All right. Jeff, I see you've unmuted. Any thoughts?
Yeah, I was wondering if I should add something or not, but I guess I was just looking at the question of why do we think management often doesn't see this as a gap? And I think it comes back to what we were saying before. It's an education thing, and I think that does sit on. I mean, fortunately, we have like the GCE and the LLP and this expert panel here, and I guess the onus is on us to sort of educate management and industry a bit more. That it's not just sort of putting faults together and shear zones together in a model, but a lot of what we do really is like a lot of what the stakeholders need and require something that's fit for purpose. And I think there's a general thought that anybody with sort of the ability to sort of use a compass can put together a model that's fit for all stakeholders. And I think one of the areas that we might need to improve our educating is that a structural model for a resource is very different than one that's for hydro or geotech or geometallurgy. So I guess just focusing on that point there, I think the onus is on us actually to help educate the industry on that there is a lot of benefit and return on investment for having the correct product available.
Very good. It's a very interesting discussion. A lot of diverse opinions from both industry and academia. So thank you all for that. And thank you for the question, Marco. It's very good. So we've gone very broad. Let's get back to a little bit more technical stuff here. This question here, this is one of the pre-submitted questions. So there is a large fault cutting across most of our pit, and everyone has argued whether it is a reverse fault or a normal fault for a long time. The fault has ore on one side and waste on the other side, and it is mapped very well. So my question is, does it matter what type of fault it is? Very good question. I think we've seen this many times, some of us. Does it matter? I see a lot of smiles.
I think we're just waiting for who goes first.
Yeah, it's a great question. Well, Luca, you're unmuted.
Okay, personal opinion, yes, it does matter. Depending on the style of the deformation, you have different pattern, different possible connectivity, different. You can understand better where your ore is gone, if it's a reverse or is a normal, so you can increase your targeting or your perspectivity, and then you can argue and make some assumption depending on the data set you have available, assumption of connectivity of structural systems and patterns as well, and that could help your design and improving your hydrogeological understanding, your overall design, whether you are in open pit or in underground. So I won't go into much detail, but long story short, yes, it does matter. Or at least personal opinion, it does matter.
Great, thanks, Luca. Anybody else?
Yeah, I think it comes down to style, right? So, I mean, there'll also be different effects. I mean, Luca touched on this, but the zone of contact strain or the damage zone might be different according to what type of fault it is. So yes, it is important. How you model it, has it any oblique movement, which might have caused, local compressional or dilational areas. Those are all important things to know. So you do need to know the kinematics of a fault. Yes, I think I would say yes.
All right. Resounding yes. Okay. Very interesting question. Well, if that's it for that one, answer is yes. Short answer. Let's move on to another.
I just add one thing that
Yeah, Luca.
the answer is yes. Now, whether it's easy to figure that out in the field, that's a completely different story. Okay, so like, to be
Sure.
full disclosure, it's that sometimes it's not straightforward. So
That's true. That's true. Yeah, there are reasons to argue. Okay. Let's go to another pre-submitted question. This one is also pretty technical. I'm working extensively with pegmatite veins and observed that a lot of these veins are filling en echelon fractures. It is thus of interest for my exploration to understand the following. Is there a fixed angular relationship between the X and Z axis and the shear zone boundary, or does the angle depend on either material properties or other factors? This is from Alfred. Thank you, Alfred. So quite a technical question. Might kick this over to Amanda again to get us started. This sounds like an Amanda question.
I like how you peg the ones that sound like me. Well, so the angular relationship between the boundary of the shear zone, this is hard to draw without this, is that so on echelon fractures are going to, the overall trend of them is going to be at approximately the Coulomb orientation relative to the overall stress field. Now, if you assumed that there was a linear Coulomb failure criterion, then that would always have the same kind of, orientation relative to the maximum compressive stress direction. But, we know from engineering standpoints that when you're in low differential stress, that conjugate shear angle can become narrower. And so it's possible that you would have a narrower conjugate angle for the overall trend, and then your on-echelon features are going to sit within that overall trend. So that can change a little bit, but you should see a systematic orientation for your particular set that should work. I'm interested to hear other people's thoughts about that. That's hard to do without sketching.
A lot of this is. Thank you, Amanda. Any other thoughts on this? Yeah, it's quite a visual question. We appreciate it, Alfred. Okay.
maybe it's more like a question even on my end, like for the panel too. Sometimes we often look too much into that detail, which relates to the regional setting as well, on how much the overall changes in rheology of the different units around us. Let's say we're looking at the national pattern as a, I don't know, 100 by 100 meter area, right? And then 500 meters, you have like 500 kilometers away or some kilometers away, you have very high contrast of rheological systems that are coeval with the deformation that created those initial systems. Sometimes it's even, your geometrical relationship might be influenced by the variability in your strain distribution during the deformation as well. So, sometimes it's even difficult in that specific location to work out whether or not you have a systematic geometrical relationship between shear zones and initial systems, or all to say that there are a lot of things that could change your ideal stress and strain conditions to what is actually happening in nature. Maybe that's
Great.
why the regional study are also important, but it's an open question on my end as well.
Yes, great addition, Luca.
Yeah, I'm just going to echo what's been said already. I think Amanda really does nail the technical aspects of this quite nicely. And yeah, I'd agree. I think you're going to see a systematic orientation of these. It is going to be influenced by your rheology, zones of low versus high deviatoric stress. But just one other thing to keep in mind is you might see this consistent orientation of these en-echelon pegmatite veins. But there's also just understanding or looking at the area for pre-existing structures as well. They might form some dilational zones or some anisotropies in the rock mass that might also help influence some of the fluid flow. So it's a minor addition there.
All right. Thank you, Jeff. Great. Okay, thank you for the question, Alfred. We've got a live question that actually dovetails off the previous question about reverse and normal faults, and maybe we can expand on that a little bit more. This is from Thomas. What are the key factors in identifying whether a fault is normal or reverse? I think we can probably say a lot about this. Maybe I'll start with Iris.
Well, the easiest way to do it is if you have a marker horizon and you can see that it's offset and you can know exactly the amount of displacement and the direction, especially if you have the slip vector on the plane itself. But that's the best case scenario, and usually we don't have that much information. There's a lot of secondary structures that we can use to determine whether it's reverse or normal. If there's any indication of which way dilation was happening, secondary veins, the vein orientation will either be vertical or horizontal, depending on if it's a reverse or a normal fault. Splays that indicate the direction of movement. Yeah, I think understanding what the secondary structures are doing in relation to the main fault will help most of all.
Great, thanks, Iris.
I think Iris nailed it with the vein orientations, which is really beneficial for understanding the kinematics of these. And then there's also the sort of the dreaded term of real shears. And when I look at fault, I think of like a brittle structure, and I think real shears is like people mention it, like people either love you or hate you, but it has to be used with a lot of caution. But in a brittle system, they can be fairly beneficial to see what your displacement is. So the proximal fracture patterns can give you an idea of what your principal stress direction is on that structure. So you should see these conjugate patterns relative to your fault plane, which can help you understand if it's a reverse or normal fault. And then I guess the one additional factor that can be beneficial as well, or two, when you're looking at a normal fault, let's assume your sigma 1 is actually in a vertical direction. So you might have a fault plane dipping at 60 degrees, but then typically in a normal fault, you will see dilational zones steepen up. So it'll be like 60 degrees and maybe it'll steepen to like 80 or 85 or something. So you will see dilational zones relative to your principal stress direction, which would be likely vertical in a normal fault system. Or if you're going to reverse fault, you might go from like, I'm just using textbook in an isotropic rock mass, right? 60-degree dip, and then it might shelve out as a dilational zone, illustrating a more of a reverse moment. So that's one other technique. And then fault block rotation and movement within the fault itself can also give you some indications of whether it's a normal or reverse.
All right, thank you, Jeff.
And striations, all that stuff.
And striations. Okay, anybody else want to chime in on this one? Not, thank you for the question, Thomas. Okay, we're gonna get out of the technical, this question from Vanessa. As structural geologists, how do you effectively communicate and bridge the gap between mine geologists and mine engineers when discussing your findings and their implications for ore determination? What strategies do you use to ensure that both teams understand and integrate the geological data into their planning and operations? Great question, Vanessa. Let's start. I'm going to start calling on people. Let's start with Ian.
Okay. Is there a strategy in the first place? Gosh, this is such a difficult question. Okay, so let me maybe do a bit of jujitsu here. And it's like, how do you, when discussing your findings and the implications? So maybe let's ask this question: is how do you reach a point where you're confident about presenting your findings and their implications? Let's ask that question first, right? You can't sort of go off half-baked on this, right? So you can't say on the one hand, but on the other hand, you know, that old adage, if you have, 10 structural geologists in a room, you'll get 12 theories. You can't do that to a mine manager. The mine manager is going to want to know absolutely, is it yes or no? Which way is it going to go? So we can talk about stochastic models and the stuff that the guys are doing in Australia and in Anglo at the moment, and looking at 100 different models, and some of them may be more right than the others. That's not what the mine manager will want. The mine manager and mine engineer will want to know absolutely, can they or can they not mine there, and can they mine at this particular angle. To get to that point, you need to basically have a robust, dense data set that covers your VOR, your volume of interest. It's a phrase we use in tech, that has been interpreted intelligently according to the setting and the kinematics of your volume. So you can't go in there and say, I think that a fault will be here, or I think that a fault might not be there. You really need to be backed up by this dense data set, its analysis, and ideally a good defendable 3D model that you can actually show them. So picture is worth 1,000 words. That's very true. You don't necessarily have to go down the mathematical route and show them all sorts of calculations as to what might happen if you do something. But what you can show them are perhaps problematic interactions between an anisotropy or a fault and their design, or underneath their ramp, or in their weathered zone. So you could very graphically and very easily, using your 3D brain, show them the potential implications based on your analysis in a very simplistic way, and say, you focus on that area. You can focus less on that area because everything dips into, the fabric's dipping into the face, etc. But you got to be backed up by something solid. Yeah, it's a very tough question. I won't carry on rambling, but I'll maybe leave that to the rest on the panel.
It's a tricky question. I appreciate it, Ian, getting us started. Maybe, yeah, Luca.
Yes, sorry to jump in. One of the thing is have a direct line of constant communication with the mine geologist and mine engineer to work out what they're looking for. And by knowing what they're looking for and what are they using your information for, that's also drives the way that the information or anything, as Ian was saying, the model, the interpretation, the theories that you're coming up with would be tailored or communicated in a way that the end user or the shareholder or the stakeholder will understand it. It's a communication thing at the end. They need to know what they want, and you also need to understand how to help them, sometimes even help them understand what they need and what they want, and the shape that it will be useful for them. And then obviously it has to be a little bit of, on us structural geologists, that we're exposed, for example, of operation, knowing a little bit of geotech, a little bit of hydro, knowing a little bit of that, so that we also can frame up our discussion that is, easily comprehensible for the end user. So yeah, there is a little bit of communication skill that needs to be built in sometimes in having this open discussion, which is by no means, as Ian was hinting as well, it's sometimes by no means an easy task by its own, right? And but yeah, I've seen in multiple occasions that open discussion, okay, what is required, what you need, what type of answer will bring your work to keep going, then help frame up the entire discussion.
Yeah, if I could just add some quick to this. Yeah, I think like Luca and Ian have nailed this for sure. And what we've seen in our operations, for sure, that connection between the mine geo and the mine engineer is so difficult to establish. And it's obviously, they do often work quite siloed. And bringing them to the table is absolutely crucial. And I guess discussing your findings and the implications is huge. And the thing is really just making sure that, again, going back to that fit for purpose. So you might have a different model for what the mine geologist is interested in versus what the mine engineer is interested in. But ideally, there's going to be some synergy between them as well. If you have a large significant fault to the deposit that's affecting lithological offsets or ore body offsets, your mine geologist is going to want to know about those. And hopefully it's going to be the same orientation and the same structure that the mine engineers can use within reason. There might be reactivation and slight differences for grade control versus mine design. But I think that, to me, is the sort of bridging that gap, is just making sure that there's some synergy between the two. And I guess that's the strategy that we've had to use in the past, is not trying to disagree with one another, but just trying to show some alignment on the big scale stuff, but also realizing that the mine engineer does need something that's a bit more specific to a brittle feature, whereas the mine geo could be looking at both brittle ductile. So it's a fit for purpose, I think, communication things, as Luca and Eve have been saying.
Yeah, if I could maybe add one more point that follows on from that silo comment that Jeff brought up, and also Luca basically alluded to the same thing. But you may have the geotechs working in Vulcan, you'll have the MRE guys in data mine, you'll have the hydrology guys in fee flow, you'll have the MRE guy just building the blobby ore model in Leapfrog or Micromine. And the things that they're seeing are not in everyone else's projects or in their software, and they'll be working on different generations of databases. So there's on a mine which has grown organically, and these departments inevitably start isolating. They become these nodes, and you're quite right. There's often no communication between these two. They're working on different packages. The exploration guys will be working on UTM, coordinate system, or ARC, whereas the mine guys may have a mine grid. And there's someone's in a drawer somewhere has got the secret formula for translating the one to the other, and vice versa. It just grows organically, and people departments crystallize out. So as a consultant, you got to come back and you bring them all together and say, hey, what are you guys seeing? Start sharing wireframes and so on. Communication is, you're not going to communicate to someone who's just looking at their own data or their own model without looking at anyone else's model in the same space. So make some effort to sending them a DXF with a small memo or report to say, import this, have a look at it, let's have a sit down. That way you start the discussion, I feel.
And if it just to add one comment to what Ian just said, is absolutely true, especially because, and that is a suggestion of all the structural geologists and that, attending this call, or geologists in general, that when we're building a model or an interpretation, trends and pattern and observation that are made by other teams, whether it's the hydrogeology team, the geochem, the MRE, they're extremely important too, to help build or test some of the theories they were coming up with, and we're translating into a 3D model. So, as much as it's possible, sitting down in a room and sharing ideas, it's extremely important to, even if we are responsible in generating, let's say, a 3D geological or structural model that will be used for mine planning at a different stage of a mining operation, it is fundamental sitting down and have an open discussion with all other departments to try and see what has been seen and what are the type of information and reason for some of the trends on hydrogeology or geochem or everything else, because it helps closing the gap and have a better even on you, the person creating the model or translating your hypothesis into a 3D model, it gives you a little bit more confidence, let's put it this way, in what you're doing as well, and help build a little bit of the reliability, or as Ian was saying, he used the perfect word, which is defendability of the model as well, because obviously we run with uncertainties, we run with a lot of question marks when we build an interpretation or we provide data. But if it's defendable given the interaction and the plausibility of the interpretation, that is extremely helpful. So yeah, as much as you can, sit down with other groups and have open discussions.
All right, thank you all for that very, very great discussion. We're a couple minutes over time, so I don't want to take up any more time. You're all very generous, but fantastic discussion. I just want to close out real quick. Just mention again that this webinar is based on our Structural Geology for Geotechnical Professionals course. If you'd like to learn more, you can follow the QR code there, or find us on LinkedIn, social media, or email us at gce@arizona.edu. And with that, I'll close out and just say thank you again to our panelists. Thank you for your time, very generous, and thank you to all of our participants tuning in today. It's a really good discussion.